Now in number 3 and number 4, it doesn't maybe look like the other questions we've done, so maybe you're saying, well, maybe we're about to do something different. And I'm about to tell you, no, we're not doing something different. What it is they've given you a binomial, but then they've said square the binomial. Well, if we're squaring a binomial, that means we're taking the binomial and multiplying it by itself. And if we're multiplying the binomial by itself, that's how we could be multiplying binomials, because it's going to be the binomial times itself, binomial times its own binomial. So, let's do that here in 3a. X plus 6 is being squared. Well, that's really the same thing as x plus 6 times x plus 6. So I want to go ahead and FOIL x plus 6 times x plus 6. So I'm going to go ahead and make myself a little table to do this here. And again, when I do this here, I'm going to make sure everything's been changed to addition, which they have been. And then I'm going to list one binomial across the top and the other binomial down the side. X plus 6 on the top, x plus 6 on the side. Each box, again, is the product of what's above it and what's to the left of it. And again, this is me doing the actual FOIL method, just not writing out FOIL and me trying to loop things together. A lot of people have more success with this table method because of the organization factor. So, this box here has x above it and x to the left of it. X times x, based on the product of power rules, this is going to give me x squared. This box here has 6 above it and x to the left of it. If I put those together, that's going to give me 6x. This box here has x above it and 6 to the left of it. That's also going to give me 6x. Notice these two happen to be the same. And then this last box here is going to give me 6 above it and 6 to the left of it. 6 times 6 is 36. So we go ahead and combine these with addition signs between everything. X squared plus 6x plus 6x plus 36, which is what you can see they've done right here. And then these middle two terms are like terms because they both have x in them. So we can combine them. So 6x and 6x go together to give me 12x's. And so my final answer is x squared plus the 12x, the combination of the like terms, plus 36. As we look at 3b there, we've got n minus m, and n minus m is being squared here. So, we have two subtraction signs when I take n minus m and square it, because that's really n minus m times n minus m. And as you know, the best way to do this is to change this into adding the opposite. So instead of n minus m, I'm going to rewrite this as n plus negative n. N plus negative m. I had to do twice because there's two binomials there. Alright, so I'm going to go ahead and make myself a little Punnett square here. And the components of both sides, the top and the left, are going to be n and negative m. Again, I'm not writing the plus sign because once we change it to plus, I don't need it. The whole point of changing it to plus is when I go to write my answer, I know everything's going to be attached with addition signs. If I don't change it to addition, I'm going to have a mess of figuring out what sign goes where and how. Alright, so let's start multiplying. This box here has n above it and n to the left of it. N times n is going to give me n squared. This box here has n above it and negative m to the left of it. Well, again, I'm just running those together. That's really easy. Negative nm. Or if you want to write it the other way, negative mn. It's the same thing. This box here in the upper right has negative m above it and n to the left of it. It's the exact same thing as this box. Another negative nm. If this box here has negative m above it and negative m to the left of it, well, remember, a negative times a negative is a positive, and the m and the m, using the product of powers rule, we add the exponents even though we're multiplying, and that's going to give me m squared. So now I'm going to put all these together, and it's going to look just like what you see over here. You've got n squared plus a negative nm, or you can write minus nm, plus another negative nm, or minus nm, plus m squared. Now these two middle terms happen to be the same here. Well, they are like terms as a result, and since they're like terms, we can combine them. So if I have negative 1nm, and then I take away another nm, now I have negative 2nm's, which is what you see in the middle here, which is why it says n squared minus 2nm's plus the m squared. This guy in the front and this guy in the back didn't change. We combine the two like terms in the middle there, and we're done.